Hi, in this video tutorial we'll be taking a look at Year 11 Algebraic Reasoning for the higher tier. So this is for GCSE 9 to 1 Maths and it's the higher tier. We're going to start with question number 1. Simplify h cubed all cubed. Well, when I have a power raised to like another power, so a bracket raised to a power, I multiply the powers. Okay, so 3 times 3 is 9. Okay, so I have h to the power of 9. Okay, that's my answer for that question. Okay, this is question number 2, guys. The first 4 terms of a Fibonacci sequence are 5, 12, 17, 29, ... Work out the next term in this sequence. Well, Fibonacci is a special type of sequence and it's made by... So the next term is the previous 2 terms added together, if that makes sense. So 5 plus 12 is 17. 12 plus 17 is 29. So the next term is 29 plus 17. Okay, so the next term in the sequence is made by adding the previous 2 terms. Okay, in my sequence. 9 plus 7 is 16, so 6 carry the 1. 2 plus 1 is 3, add the 1 is 4. So the answer is 46. Okay, this is the next question, guys. M plus K. Write an expression for the next term in terms of M and K. So the next one is going to be K plus M plus K. Okay, so it's adding the previous 2 terms together. Okay, so collecting like terms, K plus K is 2K plus the M. So it's M plus 2K or 2K plus M. Either one is fine. Okay. This is question number 3, guys. Here are the first 3 terms of a linear sequence made using counters. So the first term has got 4 circles. The second term has got 1, 2, 3, 4, 5. So it's got 4, 5, 6. Okay. The term after has got 8. Find the rule for the nth term. Well, I'm adding 2 each time, so it's going to be 2n. But 2n follows the 2 times table. So when n is 1, 2 times 1 is 2. But I want 4, so I'm going to add 2. Okay? And that will be the general nth term formula for generating this particular sequence. Okay? This is question number 4, guys. The graphs of x plus y is equal to 8 and 4y equals x plus 8 are drawn on the axis. So complete the set of inequalities that represent the shaded region. Well, it's going up this one and this one's going down. So if I follow the arrows here, it's going to be x plus y is less than or equal to 8 because it is like a full line and not like a dotted line. So less than or equal to 8. And the other one is going to be 4y is greater than or equal to x plus 8 because again it's got a straight line there. Okay, and you can test by checking coordinates that lie in this region here. So you can pick the coordinates 2, 4 and see what you get. Okay, this is question number 5, guys. 2 numbers have a sum of 6 and a difference of 1.2. Find the 2 numbers. So we must show our workings. So if I say to you, I've got x plus y, that has to equal 6. And the same 2 numbers, x minus y, is equal to 1.2. So I have formed a pair of simultaneous equations. Now that's not always immediately obvious, guys. Sorry. Okay, but obviously I don't know a lot of information in the minute here, so I'm basing it on what I'm actually given. So I'm going to solve this pair of simultaneous equations by adding both equation 1 and equation 2 together, x plus x is 2x. Okay, the y's cancel. 6 plus 1.2 is 7.2. Dividing that by 2, I get x is equal to 3.6. Okay, and thereby y is going to equal to 2.4. Okay, because 3.6 plus 2.4 gives me 6. Okay, so the two numbers are 3.6 and 2.4. Okay. Right, guys, this is question number 6. Write an expression for the nth term of this sequence. So this one, I'm adding 5, then I'm adding 7, then I'm adding 9. Okay, so this is what I call a quadratic sequence because it's going up by a different amount each time. So the first difference, okay, is going up by 2 in terms of the common difference. So the second difference, okay, is adding 2. Okay, now there are some like formulas and expressions that you have to actually remember for a quadratic sequence. What you need to remember, guys, is a plus b plus c has to always equal the first term in my sequence. Okay, so these are just things that you have to unfortunately actually remember, but if you're interested, I have done a video where I actually derive this for looking at quadratic sequences, so please click the card in the screen and check out that video. Okay, we also need to know that 3a plus b is equal to 5. So the first difference is equal to 5, and the second difference, that 2a is equal to the second difference, which is 2. Okay, I've now got a system of equations that I can just solve for a, b, and c. 2a equals 2. Straight away, that tells me that a has to equal 1. I then sub this into this equation. I get 3 plus b is equal to 5. Therefore, b is equal to 2. Okay, solving that equation by rearranging it. B is equal to 2. I can now sub a and b and work out what c is in my first equation. 1 plus 2 plus c has to equal 0. Okay, solving this equation, I get c to be equal to minus 3. So the general rule for my quadratic expression is n squared plus 2n minus 3. Okay, and that will spit out the terms in this sequence, okay, for n is greater than or equal to 1. Right, guys, this is question number 7. Prove algebraically that the sum of any 3 consecutive numbers is always a multiple of 3. So if I have letter n actually, so n plus 1 plus n plus 2, so collecting like terms, I get 3n plus 3 because n plus n plus n is 3n, and then 1 plus 2 is 3. 3n plus 3, if I just factorize this, so take out 3 as a factor, and then I have n plus 1. Now straight away, once I factorized it, I know that if I have a bracket and a 3 on the outside, this is always going to follow the 3 times table, because whatever n is, I'm always going to be timesing it by 3, and thereby that implies that it will always be a multiple of 3 by definition. This is question number 8, guys. Solve the simultaneous equations. X squared plus y squared is equal to 25 and x plus y is equal to 7. So I'm just going to label it as 1 and 2 first. I'm going to rearrange the second equation to make y the subject and then substitute that into my first equation. So minus x on both sides. Okay, and I'm now going to sub this into y. Okay, and form a quadratic for x and then solve that quadratic. Okay. 7 minus x all squared. Okay, let's just bring the 25 over. So minus 25 has to equal to 0. Okay, so hopefully it's making sense so far. Expanding this bracket, okay, let's do it carefully, guys. I get x squared plus, so 7 times 7 is 49. 7 times minus x is minus 7x. Minus x times 7 is minus 7x again. And then minus x times minus x is plus x squared. I'm now going to subtract the 25. And that has to equal to 0. Okay. I'm now going to combine all of my like terms together. So all of my x squared terms together, all of my x's together separately, and all my number terms. So x squared plus x squared is 2x squared. Minus 7x is minus 14x. So be careful with your signs here, guys. Okay. Plus 49 minus 25 actually gives us, I believe, plus 24, if I'm not mistaken. That has to equal 0. Okay. I can now divide everything by 2 or take 2 out as a factor. So I'll get x squared minus 7x plus 12 is equal to 0. I've now got a quadratic which I can actually factorize or use the quadratic formula or complete the square. Either way is going to be fine. It factorizes into x minus 3 and x minus 4. Okay. So I do appreciate that I'm jumping a bit fast here, but hopefully you are able to follow that here. And if you've got any questions, then feel free to obviously ask me if you're not sure about anything. Okay, so factorizing that, x minus 3, x minus 4. Okay, so two numbers that add to give me minus 7 and multiply to give me positive 12. That's minus 3 minus 4. Okay, so if I solve this now, I get x is equal to 3 and x is equal to 4. Okay, separately. And then therefore, y when x is equal to 3, y will be equal to 4 when x is 3. Okay, and y will be equal to 3 when x is 4. Okay, so the solutions are, just obviously be explicitly clear, x is equal to 3, y is equal to 4, and also by coincidence actually here, so by coincidence we have x is equal to 4 and y is equal to 3. Okay, so I just substituted the x values into the second equation to work out what the corresponding y values would be. Okay, so the two numbers have to add to give me 7. 3 plus 4 is 7 and 4 plus 3 is 7. Okay. Right guys, so that takes us to the end of today's video. Okay, so thank you so much for watching and thank you for reaching to the end. Okay, any questions, any queries, put it in the comment section. Okay, thanks for watching and I'll see you for the next one. Bye for now.